in this section, we are going. I was like, "Where's my arrow go?" So we're going to talk about greatest common factor, both of just numbers and of with variables and stuff like that. And I'll kind of give you my trick. I have something called the cake method. Don't worry, it sounds weird, but it's going to make a lot of sense. All right, so factor number means to write it as a product of two numbers. So basically, a factor of 12 is 6 and 2 because 6 times 2 equals 12. So there's other factors. We could think of 1 times 12 and then also 3 times 4. That's not a 4. That looks like a Y. But anyways, those are all factors. So that's kind of what we're talking about when we're talking about a factoring. So when we're talking about the greatest common factor, here we have factors of 18. I listed out were 1, 2, 3, 6, 9, and 18. And then factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Now, the ones in red are the ones that we have in common. So we're looking for what does 18 and 24 have in common. Thus, 6 is the greatest common factor of 18 and 24. So hopefully that makes sense to you guys. So you basically just list them out, and whatever one is the greatest one is what you're going for. Now, these are some divisibility tests. Obviously, you probably won't use these, but just can kind of go over them, really quickly. So if you have, I wish they would have put 6 on here, and I'll show you why here in a second. 2 is going to be, it has to be an even number, so it's going to end in a 0, 2, 4, 6, or 8. For number 3, it's going to be sum of its digits divisible by 3. So if we're talking about 7, 11, 7 plus 1 is 8 plus 1 is 9. Since 9 is divisible by 3, 7, 11 is also divisible by 3. 4 is the last 2 digits from a number, is divisible by 4. The other thing I do is just take half and then half. So for instance, if we look at 128, half of that is 64, half of that is 32. So because of that, it's divisible by 4. The neat thing is that if you take this again and cut that in half down to 16, then we know that 128 is actually divisible by 8 as well. And then we can keep going. It's divisible by 16. It's divisible by 32. Anyways. And then 5 is just going to be 0, 5. The reason why I wanted 6 on here as well is because basically 6, if a number is divisible by 2 and is divisible by 3, then that number is also divisible by 6. So, I don't know, like 216. It's an even number, and 2 plus 1 is 3, plus 6 is 9. So 9 is divisible by 3, so this one is also divisible by 6. 8, again, I honestly just do that half and half and half. 7's not on here because it's the strangest one ever. Honestly, I just type it into a calculator. And similar to 3, 9 is that the sum of its digits is divisible by 9. So again, like 729, 7 plus 2 is 9, plus 9 is 18. Since 18 is divisible by 9, 729 is also divisible by 9. And then 10 just ends in a 0. So why do we need to know that? So the first thing we're going to do here is we're going to talk about finding the GCF. So this is where my infamous cake method comes in. So method number 1 that I used to do is just list out the factors of each of these numbers. Now, 50 is going to be 1 times 50, 2 times 25, 5 times 10. 75 is 1 times 75. I may not recognize that 3 goes into there, so it's 3 times 25. 5 times, what is that? 5 times 1, 15. Yeah, so anyways, it gets into like craziness where it's just like there's just a lot of like struggle. So anyways, what I found and something we teach here at Mathnasium, and it kind of makes sense, is something called the cake method. So what you do is you start building your layers of cake. So what is a number that goes into both 50 and 75? Well, the first thing I recognize is 5. Okay, so I know that 50 divided by 5 is 10. And I think that 75 divided by 5 is 15, if I'm doing that right. Okay, now, you look at the 10 and the 15, and you say, is there a number that can go into that? Well, of course there is. It's going to be 5. Here I'm left with 2, and here I'm left with 3. Now, is there any number that goes into 2 and 3? The largest one I can think of is 1. So, to find the GCF, all we do is times 5 times 5, and that'll give us 25. Now, the neat thing about using this method, if we're trying to find the least common multiple, all we do is 25 times 2, which is 50, times 3, which is 150, and then we get our least common multiple as well. So not that we're looking at least common multiples now, But if we were, that's how we would do it. Now, the neat thing is this thing actually works with this as well. Now, the biggest question is, do I have to find the biggest right off the bat? And the answer is no. So here, I take a 2. That's 12. That's 30. This is 66, I think. I still see that I could take a 2 because they're all even. So that's the number I always start with. So I look to see if it's even. If it's even, I go for it. And then hopefully you can see that the 3 comes out of here. That's 2. That's 5. That's 11. So then the only common factor that goes in all these is just 1. So then the GCF for here is going to be 2 times 2, which is 4 times 3, which is 12. And then again, if you want to find the LCM, you would times that by 2 times 5 times 11. So these are basically our little cake tiers. That's why it's called the cake method. Hopefully that made sense. And then this one, if you actually do this, you'll see, like, even if I started here with my cake method, the only number that goes into these ones is 1. So the greatest common factor there is 1. That's kind of weird, but that's kind of the answer for that one. Now, let's talk about variables. Okay. So when we're talking about the GCF of this, we want to pick the one with the the least variables. So we can figure out our number first. If I look at this, I notice they're all even. 8, 5, 4, 14. That's it. So, yeah, that's it. So 2 is my GCF for my numbers. But here I've got 9 R's. Here I've got 15. Here I've got 12. Here I've got 10. So we actually take the least amount, which in this case is going to be 9. So if I'm trying to find the LCM, this is where it gets a little bit, we're going to take the most. So in this case, the LCM would be whatever 2 times 8 times 5 times 4 times 14 is, but then it would be R to the 15th because that has the most R's. Hopefully that makes sense. Okay, this one. Remember, we're just taking the least. This has 4 S's, 3 S's, 9 S's, 5 S's. I think the least is going to be 3. This one has 5 T's, 6 T's, 2 T's, 0 T's. So I think this one's just going to be S cubed. And that's it. So remember, the GCF is going to be the least amount. Okay, now we talk about factoring out the GCF. So here's what I do first. It's kind of a 3-step process. So I have 6 and 12. Let's say you just see 2. Perfect. So my GCF is going to be 2 times 3, so that's going to be a 6. If I look at my least amount, I have 4 X's there and 2 there. I believe that it's 2. Now, to factor them out, basically what I do is I divide this by 6x squared and divide this by 6x squared. Okay? If I do that, these 6's will cancel. If I have 4 x's on top and 2 on the bottom, I think 2 of them cancel, and I'm left with x squared. Bring over your sign. Again, this time 12 divided by 6 leaves me with a 2, and this x2 over x2 is just going to cancel as well. So there is my final answer. So again, find the number, least amount of x's, divide each of those evenly, and then that is what you get. So again, this one, if I'm looking at the number, I think I'm going to get a 5t to the 4th. And you can do the work over here if you want. 30 divided by 5 is just 6. T to the 6 over t to the 4th, that's going to leave 2 of them. This is 5. I've got 5 on top, 4 on the bottom, so that's going to leave 1 of them. 10 divided by 5 is 2. T over 4th is t over 4. Don't forget to bring this back. And that's your final answer. Here, least one is going to be r to the 10th. Right? Divide that by r to the 10th. Divide that by r to the 10th. Now be careful. You always put what you took out on front. That's going to leave 2 of them. Now be careful. R to the 10th over R to the 10th is 1 still. So you still have to put that piece of it. And then this one is kind of long. I don't even know if there's one of these on your test or on your homework. But I think it's going to be 4. I've got 5 p's, 6 p's, 4 p's. So I'm going to take the least amount. QT, Q3, Q7. So I think that's going to be QT. Did I say cutie instead of like QT? I don't know. Q2 is what I meant, not cutie. Oh man, it's been a long week, guys. All right, this one, 8 over 4 is 2. Left with just a p. 16 divided by 4 is 4. Left with 2 p's, 1 q. Minus 3, p's disappear. Q to the 5th on top. And then don't forget to put whatever my greatest common factor is out front. Okay.